All right, our recording has started.
Okay, no, it's less pretentious, but still pretentious enough.
As
Um, okay,
so, for all the people who are not watching this, I'm Hyomoto, and this is Julian. Say hello, Julian.
I'm Julian.
Very good. He's here to provide the accent. The Yeah. So we're testing out our podcast here, and we kind of want to talk about some fundamental concepts that maybe get missed in GML, or somewhere in that range of stuff that you don't really see in tutorials, or even just a frank discussion on different concepts involving data and whatever else. So
Like things I you kind of see expected of people, but never taught to people.
yes, the whole trial by fire thing. I
Yeah,
made a joke the other day that computer science is mostly learned through trial and error, and perhaps that's not the best way to learn.
we can argue about that later,
All right,
whether it's the
so
best
the topic that
thing to
we have
learn.
sort of selected for today will be states, state and state machines. It's kind of a broad topic, but that's kind of why we want to break it down into more fundamental concepts. And so this isn't a tutorial. It's more a discussion about programming concepts
Mm.
and how they fit into our daily lives.
Yeah, well, when talking about state machines, when I started out learning state machines, one of the most difficult things to learn is what even is a state. Because you don't really know you need a state machine or what you need a state machine for until you know that the one thing you're trying to do is even an encapsulated state and that you can do it on its own and that you can separate that logic from, I don't know, climbing a ladder to
Mm.
dying.
Yes. Yeah.
And Hyomoto made the excellent point that everything really is a state earlier when we practiced. And well, when thinking about everything as a state, I think that kind of complicates things a lot, even though it's accurate. But a state, like I said, is something, an action really you can encapsulate on its own that will run on its own and that you really should run on its own. And
That's probably the
it's,
key right there.
yeah, it's difficult to define something like you should run it on its own. State is something you should do on its own. And that's really a bad definition. So I'm not sure if there's a better definition when you say everything is a state.
Well, look, we could crack open a dictionary and find out what it has to say about state, but I think you bring up a very good point, which is when it comes down to it, when we're talking about state, what we're really getting at here is okay. Let's say that let's look at Mario. Let's talk about Mario for just a moment and say when Mario dies, jumping is no longer relevant, right? And so why do you have jump code right next to die code? Like here's Mario's death sequence, but I have button presses for jumping right next to it. And when we really get down to talking about state, and I'll kind of broaden this in just a moment, but uh, it's that idea of not just saying like if state is equal to alive, do jumping, and if state is equal to dead, then don't do jumping. It's a little more fundamental than that. It's that when Mario is dead, jumping just isn't an option anymore. It doesn't exist as part of that state. That we had and in Game Maker, the big piece that I like to bring up is like objects as an expression of state. What is Mario? Mario is an object, and as an object, he encapsulates everything that makes up a Mario. His ability to jump, his ability to reach the goalpost, his ability to collect score, whatever you really want to encapsulate into that state. Uh, you know, the Goomba code isn't in with Mario, and if it is, you screwed up. You did something a little ugly with your code. So don't do that. But yeah, that's that separation is, we have a Goomba, we have a Mario. Well, if we divvy it up even further, we have an alive Mario and we have a dead Mario. And if we want to divvy that up even more, we have a jumping Mario and a ducking Mario and a dying Mario and a shooting fireball Mario. And that's kind of where we start to get into the really tricky stuff because the most common answer to this, I think, or at least that I read, is the finite state machine. Ooh, the fabled finite state machine. And I am going to break that down. Finite, meaning there's only so many. State, meaning states. And then machine, meaning we tacked another word onto it. So our
Yes,
finite
and
state machine.
before anyone asks, we don't know if there's an infinite state machine. That was a topic I brought up earlier. But when implementing a state machine in GameMaker, you often see those big switch case blocks. And personally, I still don't understand. And I do it differently. That's why it doesn't matter. But I don't understand why a big switch case block would be better than a big if else block. And what it really comes down to is when you implement a switch case statement in GameMaker, not a switch case statement, a state machine, you often see the pre 2.3 implementations being you have an enum. Um,
Mm-hmm.
you set a state to something like idling or jumping or attacking. And then in the switch case statement, you do like if idle, well, case idle, um, you can jump or you
Mm-hmm.
can walk.
Sure.
And if you're jumping, you can't walk anymore. Like you said, for example, a Boolean to true or false. Um, but really, what like when you learn about it, it's a little strange to learn because well, I'm setting my state to idle, and I'm being told that an enum is just representing a real number.
Mm-hmm.
No, not a real number, I think, but an integer. And now I'm setting the state to an integer, and then I'm checking if it's the integer, and then I can do my thing. And that seems overly complex, but
Yes, it adds exactly one additional step you probably don't
mhm,
even want. Because now I have to manage a set of enumerators and a set of if and else blocks. Yeah, that's and my
it
common
doesn't make
phrase
much
is a
sense.
lazy coder is a good coder. And when I say that, this is a great example of that because do you really want to manage two lists? Ugh, no. Eh. I want to write code once and then never have to think about it again. Goodness
It's also
gracious.
hard to debug because if I want to like debug my state, I have to debug like I'm going to print out the state it's in right now, and then it just prints me a zero, and that doesn't make sense because the state is called jump. And for me, that was a big learning step to understanding like I can just use the enum, for example, in an array, and then have the array named, and that's just another step on top. It
And I
was
will say the one place that you see that is because, and you can tell when that happens because people will ask, well, how do I get the name of this enumerator? And you're like, there is no
exactly.
name of that enumerator. It's just a number. Yeah, keep going, keep going.
Um, and the good thing is, like, the good news about that is that 2.3 did implement functions, and you can now do it better. And Hyomoto wrote a very nice state machine. It's also really easy to use, and I think Pixelated Pope, I'm not 100% sure on that, wrote a state machine pre 2.2, pre 2.3 that did something very similar, where you could define a state, and when
Mm-hmm.
now we're getting in the juicy part that was previously really difficult to do, especially for beginners, where you enter a state, you are in the state, in like the step state. That's going to, I think you're going to get to that in a second too, and then you leave the state, and this really starts to make more sense now because when you enter the jump state, for example, you want to set your walking boolean to false. It's
Sure.
a bad example because ideally walking should be
Yes,
encapsulated
I
to
get.
true.
I'll give you a slightly different example, and this is there is one boolean that
Let's
I
say,
often
let's
do
say,
use. I use an on ground
oh,
boolean,
that's a good example. If
and
you're
so
jumping first,
and
first
when
step,
you touch the
you're
ground, you definitely want to set your on ground state. But the question is, do you want to write this 9 or 10 times across your code, or
yes,
do you just want it at the literal point when you've touched the ground? I think I can figure out which one I'd rather write for.
hmm
Once. Write it
okay,
once.
that's a good example because I was talking about walking. But on ground, if you start jumping, you set your on ground to false
Two
because you're in
false.
the air. And maybe if for whatever reason you're doing it, you set your in air state to true.
Sure. And I'll give you another little example of that. Let's say you wanted to implement a double jump. Well, when you touch the ground, you can set your double jump back to being true, you know. So when you go back into your jump state, you can be like, you don't have to worry about it. You don't have to be like, hey, am I in this? No, it's a state. We're in a state. We've created a
Mm.
state. When I touched the ground, my state became double jump is true, and I don't have to think about it again. Yeah. Anyways, I like what you're going on there. So if you got any more, keep going. But otherwise, I'll put something in.
Yeah, the great thing about like function is that we have this on enter, on step, on leave of that specific state. And that suddenly starts making so much more sense because now a state something isn't like a number and a switch case thing, but a state rather is something you enter, it happens, and then you can leave it again, and it suddenly becomes a thing that actually exists, like a thing with a representation. Because touching the ground, you started, while it's happening, you do something, and when you end it, well, something else happens because if you don't touch the ground, you're flying or something.
Yes.
And that starts making so much more sense.
Oh, and it's easy. It's much simpler to code. At some point, maybe we'll actually look at some of these things in more concrete terms. Now to speak on the pre 2.3 stuff, there actually was a good way to build state machines, and I kind of already mentioned it before. We don't really think about it, but in GameMaker Studio, objects they're not special or unique or interesting. Well, okay, they're unique and interesting in their own way, but when it comes down to it, objects, instances are special and unique and interesting. Objects are just an organization method. You know, people often talk about the lack of namespacing in GML, and I'll tell you what, objects are a form of namespacing. And you know, to avoid getting off tangent here, the fact of the matter is I could write, you know, oh Mario is dead. I could write oh Mario is jumping. Oh Mario, and you know, even from a really funny perspective, I could write instance change, and I could change Mario alive into Mario dead, and then suddenly I've achieved the same goal where suddenly I've segregated out all of that code, and I can even create these. On enter and on end steps in kind of a clunky way, unfortunately. But it's
Mm.
still, you know, leagues above doing the state machine because I've created an absolute nature of things. When I say enter this state, it's true. It doesn't rely on me having properly coded an if statement. There is no other alternative in this universe. It becomes absolute. Mario, you know, oh Mario is dead. Well, guess what? Unless oh Mario is dead has jump code in him, it ain't happening because it just is not possible. And
Well,
so,
mm,
oh, go ahead.
continue.
Well, okay, so yeah, so we talk about this really broad scope of state and sort of this idea, and I I don't generally like to tell people, you know, like what's good and bad in coding because you kind of have to learn it, right? And even
Except
bad
for me.
code has its place. It's like a pencil drawing, you know, or a pencil sketch. When you examine it up close, maybe it's a bit rough and it looks a bit goofy, but the fact of the matter is if it looks like a person and that's what you needed a picture of, you did it. Okay, go home. The unless you want novelty points, you know, you've succeeded. And so there are places to use something like the fancy enum switch case. I wouldn't ever use that. Actually, this is kind of what I'm
Me
getting at.
neither.
Is that's one of the few places where I think I can universally say that's terrible. It's easy to understand, and I think that's why so many people gravitate towards it when they first start learning how to do state machines, as because it's very easy to understand. It helps express that concept. The problem is it's really unmaintainable, and when you really get into it, does it? Does it actually really? Does it express this in a really useful way? And I would say 99% of the time, no. 99% of the time, there's an easier, faster, more useful way of doing it. It's one of the few coding concepts that I can actually point at and say, once you learn a better way of doing it, you'll never ever write code that way again because it's just
And
clunky.
that's mostly because of what we already mentioned, that it's just another layer, an unnecessary net layer, really, on top of something that might not need a layer in the first place, because a lot of state machines are really easy and they start to make like state machines make more sense when you have a lot of states and complex states. But what a lot of people do is like you are idling, you're attacking, you're, I don't know, walking and dying. Those are maybe 5 states, and especially when you start implementing that switch case example, um, really it's more difficult than having like 5 if cases and maybe more nested inside. It also doesn't really make sense to someone who just learned about state machines because I mean it's easier to just have those 5 if statements. So why waste my time in having a switch case statement that I don't really understand? And I think this is done. It's one of the rare instances where something is easier in Unity. Um, because in Unity, I think it's called the Animator Component, where you have an animation you can play, and when the animation finishes, it transitions to another animation, and you can have it. I think you can have it execute code or set a variable to something. Um, and thinking about state machines like that suddenly makes much more sense because now state isn't something that's happening because it's a number in a switch case statement, but it's something that's continuously happening, and then when it finishes, it does something. And so a way you can think about it is like you have your animation playing. When you start that animation, you do something, and namely starting that animation, for
Sure.
example. So when you enter the state, you play the animation. And when it happens, well, the most obvious thing is incrementing the image index. And GameMaker does that automatically, so just imagine it didn't. And you do your other thing, like if the key is pressed, you walked because you're in the walking state. And when it
Sure.
ends, so you transition, um, you put the next state to be done. Let's say it's done, or you set the next state. And this state, when it happens, it suddenly doesn't have the walking logic in it. And so thinking about states like separate objects, like you mentioned with instance change, which is the function I really rarely ever hear about for multiple reasons, but um, instance change really makes a lot of sense in this example because a state machine really is just changing code that can run.
Yes. Breaking it
And that's
up.
what makes it great. Yeah, that what makes it great. And that's what people really often miss about it. I have a good example I saw in a Discord server, I think 1 day ago. Someone was asking about how to do a fighting game because they had
Hmm.
like their characters. And the only difference between characters was like how fast they play animations, what animations they have. And someone suggested a state machine, which is terrible advice because it has nothing to do with the topic at hand, firsthand. And the other thing is, mm, it makes a lot of sense. Um, because, well, on one hand, a different character is a different state of character. Let's put
Sure.
it that way. Um, on the other hand, you don't exactly want a state machine because it's a different character, so it's a difficult um,
Well,
thing to
I would
suggest.
cut you off here just to say one little thing because I get what you're getting at because I do want to talk about something real quick and then this will make and then I'm going to add into that, which is
Okay.
that the main reason why I think you see people learn the switch case is because having state named makes sense. So you say state walking
Yes.
and then you say if state walking. Well, if state walking, else if state. So when you do the case switch statement, you go case state walking, case state jumping, case state ducking, and you do start to see that separation of state, and so
Hmm.
it's understandable. For the fighting game, though, it actually shows why it's detrimental or why it can be detrimental. Because let's say all of our players, let's look at Mortal Kombat. You know, like and you know, like what's true about a character? A lot of stuff, right? There's a lot of overlap. They punch and they kick and you know whatever. But where does it get different? Special moves. You know, they have different special moves, and their special moves can be done at different times. So here's the thing: are you going to write one big complex, you know, standing state that accounts for every special move that every character might have? Maybe. I mean, maybe. There's ways that you can get around it. I mean, we'll talk about this maybe at a later date how you can consolidate code and reusability. But just for the sake of this discussion, you know, like there's a lot of code that the idle state shares, but there's a lot that it doesn't. But here's an even more important fact. What if you wanted to create a character that behaves differently? Let's say you had a character that I don't know, you wanted them to be in a wheelchair or made out of springs, or you know, suddenly you're highly limited because you've declared your state in such finite, ways that, what do? You go into your enumerator and you add state jumping. Oh wait, hold on, state jumping is already reserved. So this is a special state jumping. This is state jumping springman. And you start writing these really complex and just needlessly convoluted workarounds to get to the same spot that you were, where what you really want is to say this character has state, and they may even share some state. They may, I don't know what. It's your game. You have to decide. But by and large, when they're jumping, they have different abilities. They have different jump heights. They have different this. And while you could, organize that code to share some of it and then just, feather out the parts that are unique, if we really start from a rookie standpoint, the best way would be to write individual states for every character. And then what do you have? So now what's our state machine? Our state machine is a framework to make that easier, right? But even if we ignore that particular part of it, kind of what you were saying, where it's like I would use a state machine. What does that even mean? What is that? What does that mean to use a state machine? As I said, machine is just tacked on to the end. So they might as well have just said, I'd use state. And yeah, you kind of have to, because everything's state. So what kind of state? What would be a helpful implementation of state for a fighting game? And that's why I'd written the state machine that I did, was because it's very generalized. It's completely abstracted. You write everything in very literal terms, because that's what I would like to do. I would just like to say state walking is equal to whatever should happen when you're walking, and then state jumping, whatever happens when you're jumping. I don't want to have to write switch cases and enumerators. I don't want to have to do a bunch of if statements, because at the end of the day, my state machine looks like this. It goes state update. That's it. You're done. You've created a state machine that works infinite. There's your infinite state machine that works in infinite ways, without having to write a bunch of code. Ugh. I love writing code, but I write so much code to avoid writing code. That's the paradox of this whole situation. I don't want to write any code. If I can avoid writing any code, that's great. But unfortunately, I have to write code to not write code. What a troublesome existence that is. But yeah, so we've kind of talked about this really hugely general thing, and so now kind of talk about little specific examples, I guess. One of the things that was brought up was this before, during, and after. And GameMaker does have a little bit of that sort of Unity thing, which is there is an animation end event, but the problem is it's not unique to the animation being played. So it creates that ugly switch statement thing where suddenly you're like, on animation end, if sprite index is equal to this, do that. If sprite index is equal to this, do that. So we start writing out this long code. It's okay. Okay, look, I make faces and I mean to it, but when we get down to it, it does work. And if you want to use that, good. That's why it's there. For Christ's sake, that's why it's there. But it can be a little bit clunky to use for that reason. But I would argue that doing that, you've actually solved one of these problems. You no longer have any enumerators, because your enumerators are the animation, right? You can say, hey, if this animation, this. Ooh. The reason it falls apart is because let's think about walking real quick. Your character's walking, and that sounds really simple. Okay, the player shoots while they're walking. If they enter a new state, can they walk while they're shooting? Okay, well, we've tied it to an animation. So now, no. Yes, maybe, because we have to write a state for both walking, shooting, and walking, and sliding, shooting, and ducking, shooting, and jumping, shooting. We need these special case, and ooh, now we're going to get into the really bad stuff. When I land on the ground, okay, well, now I have to have landed on the ground while shooting, landed on the ground while not shooting, landed on the ground while the firepower was activated, we're getting into some unmanageably ugly code. Like, ooh, we're going into pages of code. And I would like to stress there's nothing wrong with that, except that it's painful. That's all.
Yeah.
That's what it comes down to. It's the only reason I get to say this is because I know of ways to manage that and reduce it, and that's kind of what I'm hoping we'll talk about in this little part here. And so one of those big ones is, I've laid out this highly extensive framework. Well, here's a good example of a place where you can, simplify it. Is because we mentioned about the whole on ground thing. Well, if I set on ground whenever I set, I guess when my I'm trying to think of where I did it in Mario. I think I did it in the idle state, because my idle state was anything but an idle state. But I knew it followed anytime the player had touched the ground, because that's just what I set the player to when they landed and stuff like that. Because when they're jumping, it'll say, hey, if they touch the ground, set the idle state. And then the idle state would be like, hey, is the player running? Then set the running state. But a good example of this is, as I said, you could have all these different transitions into the ground, right? And so where do you put that check? Do you put it when the jump event ends? Maybe. If you know that your jumping event is always going to end with you touching the ground, that might be a good place to put it. Otherwise, you might have to find somewhere else. But this is why it gets useful, is because otherwise I have to find all those states where I can go from jumping to the ground, and I have to say, okay, set on ground or set not on ground. And I have to do that for every single one of them. But the whole point of consolidating these codes into state is to take that truity, that idea which this state expresses, and bundle it up into that one spot. And so that's why we have this on begin and we have this on end, is because I go, look, every time the jump state happens, the player's not on the ground anymore. It's impossible for them to be jumping and on the ground at the same time. That was the whole point of jumping, was to leave the ground. So, why do I have this in 6 different places? When I'm running and I jump, on ground is equal to false. When I'm standing and I jump, on ground is equal to false. No, when jump enters, boom, okay. Now we're on ground is equal to false. We only put it in that one place because we know it to be true about jumping. And then, and this is one of those things where, and this is kind of why I'm over explaining this, is because I do think it's hard to truly understand the value of having the on enter and the on leave. And if we're being honest, I don't use on leave very often at all. I have it in my state machine, but it gets used almost never because it's so rare that I need an on leave state. The on begin state, however, I use all the freaking time. And so, but that's the reason why, is because, here's my example I'm going to use, which is very concrete. Let's say that when the player is ducking, and let's look at Super Mario Brothers 2 for a moment. When you hold down, when the player's ducking, it charges up a charge, and then you let go, you do a super jump. If you take that ducking on enter, you can set something like charge jump equals 0. And this is a variable that has no application outside of this one particular state, but I know I need it for this state. So I set it to 0 in my on begin, and now I can run the rest of that state code with the knowledge that I have set my state in I don't know why I'm blanking on this word, in a condition that is always going to be true. I know that my charge jump was always set to 0, so when I'm now during my step event, I can say, okay, if plus charge jump is equal to 60, power jump is ready to go. However you want to do that code. But I know that when I press duck, my charge jump is always going to be set to 0, and I'm going to be able to run that code reliably. Instead of having to look at okay, I pressed duck because charge jump has no applicability to walking. It has no applicability to running and standing still. So I take that variable out, and I put it in the one place it matters. when I duck.
Mm.
Anyways, go ahead. You're
So you mentioned you use very little,
very
which I
little.
agree. I use it a lot in one specific um,
Yeah, but you're a monster,
condition in
so
my game. Yes, in the game I'm working on, it's a turn-based game, so it's very different from the platformer, but also very similar in a lot of cases, which might seem unexpected. But consider the following case: something attacks something, and then the object getting attacked plays an animation,
hmm
and now it switches the game state to the other object that was just attacking itself. Now what happens? Do I set its attacking state to true because the animation still hasn't finished and the player will see this weird jump in animation.
hmm
So the thing that happens is I can either let it finish that animation and just block everything else and then just try every single time to make that object attack now, or I can do something way more elegant, which is I have my player attacks, and when it finishes attacking, so when the animation ends, it removes itself from a data structure that is checked whenever something is removed, whether it's empty, and then I have another check in whether it's empty the next frame because something might be added that frame. And now what happens is it removes itself, but also the other thing is still not finished. The other animation is still not finished. And when that animation, that hurt animation is finished, maybe it dies. So it dies, and then the stack is checked whether it's empty. And because it's empty, the game notices, okay, I have to try to do the next turn now, but that object is dead. So we know the turn is finished
yes.
and the game is over. Or alternatively, now, okay, it finished hurting, which sounds funny, but it finished hurting, and now I can make it attack back. And in this case, it is not an explicit state machine because I don't have this switch case block we know about, but rather I have something that happens and it ends. And when it ends, I do something very specific, and that gives not the object a state, but rather the game a state, something like the game is idling, which is much harder to do when you have a big switch case statement in
yes. Yes.
the like what even means the game is paused. When I pause my game, does that mean I have to set every movement variable to 0 and then reset it to the maximum possible or whatever? But rather just what it does is it doesn't allow for anything to happen because there's nothing that can happen because there's nothing telling the game to happen.
Yes.
And that makes
100%.
much more sense as a state machine than having a switch case statement because why would I do that?
Well, I can tell you this much. So, kind of what you have layering in there is also an event queue of some kind. I mean,
Ah,
yours is a little
yes,
bit more complicated and
I
interesting
know.
than
I
that.
tried to
Because
put
I
in.
know when you were writing this, I had suggested a certain type of event queue, and you said no. You were insistent upon doing your own crazy, wacky stuff. So but it is layering in a bit of event along with state. But I mean,
Mm,
I said everything is state, and what is an event queue if not a list of states,
yeah.
so to speak. The But what I will say is that waiting is an interesting state because
Oh, yes.
let's dive into this ever so slightly because here's an interesting question: is waiting a state? Right? I pause the game. Do I set every enemy to a wait state? Now, maybe, like most coding thing, maybe. I guess it depends on your goals. But the funny part is when you unpause the game, I have to go back to my previous state, right? And depending on how you set things up, that could be good or that could be bad. Because here's the good part: if I have a pause state, I can literally just have no code in there. Nothing's updating, and well, okay. Look, GameMaker does a lot of things on its own, so let's just put that off to the side and pretend that it's not doing a bunch of stuff on its own, like animation and things like that.
Mm,
But if I have no code in my pause state, all my variables should be the same when I resume my previous state. In fact, I could do something like, previous state is equal to this state, and then change state to pause state. And then boom, I'm paused. It's, again, there's nothing else that can be true because I am now in this paused state. Um, that tricky part that I brought up is, and this is another one of those on leave things, is if you do build your state with a begin and an end, and then you were to pursue something like this, you could end up in an issue because you're like, oh, set from the jump state to the pause state. But I'll go one better, and this is why I don't use pause state. Could be useful for a lot of things, but this is why I don't usually do it. As I said, in my state machine, it ends up just being state update because that's all you write. I don't know if we said that here, if we were talking about that earlier, but anyway.
I think we did, which is why I was going to say, why don't you just not update the state?
Yes, because now I can just say if game is paused, or if game is not paused, state update. And now suddenly I can pause the game very easily because not only is my state completely encapsulated, but I can simply not update in order to prevent things from happening. And that is where we really like. That is just one of those places where I feel like it's an aha moment where suddenly you're like, wow, excuse me, you're like, wow, pausing is so easy. Because otherwise you were like, if game is not paused, but oh, my character's still moving and he's still animating, and you have all these troubles that just that keep happening. They just come up. They just keep happening, and yeah, it's kind of with that switch statement. Now you could put the if game is paused around that switch statement, but if I were to argue why that's complex and sort of ugly, it's because where's that block end? Somewhere down there. Keep scrolling. Keep going. It's further, and that's kind of the trick behind the big switch statement is everything's down there. It's down there. Keep going. And you see people try to manage it with like regions, close up my regions. And that's not a bad idea in broad sense. You're trying to manage that complexity. It definitely shows a thoughtfulness, and it's an option. I mean, that's why it's there, is to try to solve it. But I would also argue, if there's one thing I like about Python, and I do actually like Python. I only hate the linter, but if something there's a lot of things I hate about Python. But anyways, but there are things I like about it. And one thing that's funny about Python is they insist that you have no deeper than 3 levels. You should never have if. You're done. Don't go any further than that. And in Python, it believes that if you've gone this far, you need to create a new function somewhere. I don't know that I fully agree with that. Again, that's why I have a love-hate relationship with the language. Yes, it will. It doesn't. In fact, sometimes it'll. I don't know if it's just the linter, but I do believe that if you hit a certain level of nested, the program won't even run anymore.
Oh yeah, I never noticed.
But yeah, but I like that. I do like the idea because it is trying to convince you to simplify your program, and you can do that stuff. And this will be sort of the limitation of the format we're doing right here, is we're not really going to be able to be like, here, watch this, I'm going to simplify something. But by taking those states and using some of these techniques where you that switch statement, the problem with the switch statement is this is where your code has to be. It has to be here. It can't be anywhere else because this is where it is. Yeah, I could take it and put functions in there, and okay, now my code's over there. And I would argue that that's not even a bad idea because you're managing complexity again. You're putting your blocks so that I want to know about the sleeping state. Press F1. Here's my code. Nice. That is nice. But I'm still constricted to this block right here. And again, with that if pause, where's the end of it? It's down there. It's down there. It's always down there. And the other one you got to watch out for is it's over there. That's you see that a lot with the really. Sometimes I'm guilty of it too. I try to minimize it, but sometimes you write like a really long block of code, and you're like,
I never.
You shouldn't. It's not good for you. But sometimes you're like, where is it? It's over there. And if you have to scroll over to find it, you probably. That's another thing about Python, is it wants you to write really small, and I hate it. But at the same time, I do appreciate. It's too small, but I appreciate what it's trying to do. It's trying to ask you to consider what it is that you're writing, and with state, that's a huge thing because when you can encapsulate your state in a very like let's talk about your. I only understand so much about how you've done your system, but you have shown it to me before, and one of the interesting things about it is that it does allow you to very neatly encapsulate your ideas. You'll say, uh, play animation, wait until then do, and that's what you want, right? Like that's what you'd want to see. You want to write code in a very directive fashion. Here's the best example I can give is imagine a cutscene for a second here, and I want my character
No.
to walk over here and then walk down and then maybe open a dialogue. Okay, we're not going to go super complex here. How do I do that? Well, in the case of like a state, it doesn't just have to be character is jumping. It could be scene directions. Like for example, I could do something like, here's my state is to move right and increment a counter, or yeah, well, let's just say increment a counter, just for the sake of argument. I increment my counter. I want to walk right for 64 frames. So once it's 64, go to my next state. And then in my next state, I say, okay, walk down for another 64 frames, and then go to my next state. And then for that last one, I'm like, open text box, and that's all it is. It's just, on state enter open text box, right? And so now I have this really legible code. If another way of doing that might be to do that big switch case statement again, where I say switch plus plus counter, and then I'm like case 64, case 128 case, I don't know, 196. Did I even add that up correctly? I don't know. Hard to say because I had, all this logic is broken into it's all in this block. But when you break it out in those little states, even though it might take up the same amount of room on the screen, the truth of the matter is everything's localized to that state. Suddenly it's move 64, right? Move 64 frames. Move 64 frames. It's not wait until 64, wait until 128, and then I'm like, oh, that's too much. I want to reduce this one. Oh, but I got to edit this one now too. It becomes very very untenable. And that's what's funny about the switch statement is it gives this illusion of maintenance, but in reality, a lot of times it's farcical. The place where a switch statement works the best is when everything in that statement is actually related. A good example of this would be if I'm building like for the automated testing suite that I wrote, you can pass a number of arguments, and it has to know how many arguments you pass, so it knows how many to pass. In this case, every single line on that case statement is identical, except for how many arguments get passed to the other function. And that is a great use for a switch statement because it makes it very neat and legible. But because everything's identical, I haven't added complexity. This is one of the few times where I've actually reduced complexity with my switch statement.
And I'll agree. Also, I wanted to bring up one more argument against
the
pause state. Because now you have an entirely different issue when you resume the state. Because are you going to resume at jump? Because if jump was your last state and you resume at jump, and let's say when you start jumping, you set your jump counter to 1. Suddenly, when you leave the pause menu, you can jump again, even though you're not supposed to jump again. And now you have, at the start of the statement, have to do a thing where, like, in the last frame I had paused, I can't jump. And now you have another layer of complexity inside your statement.
Well, the biggest flaw of the switch, this is what you're getting at, and that's why I'm going to throw this in here real quick, is the biggest problem with that is because with the switch block, there is really no good way to do that on enter, on leave.
Mm-hmm.
Because otherwise you need 3 separate switch blocks, and you put those somewhere.
Exactly.
And now my enter code is separated from my step code, is separated from my leave code. Or I can put it in each step, but then that requires a lot of maintenance, blah, blah, blah. Anyways, sorry, keep going.
And I've kind of thrown a wrench at me because I forgot where I was.
Haha, take that! That was my job.
No, but the issue becomes that once you add that additional layer of complexity, like by pausing, you're probably going to end up having another thing you just changed a setting, so you need another layer on top of it because you just changed that setting, and you need to
Mhm.
check if that setting was changed last time, like in easy mode. So when the enemy is on easy mode, it instead has this attack pattern, and it suddenly grows unmanageable. Even though, well, you said that maintaining that big switch case statement is just pain.
It is
You
pain.
suddenly you just triple the amount of pain by just having three different game states. And
Yes.
I'll argue, I'm sure some very, very, very terrible people will argue against it. That's not something you want to do.
Yeah, generally anytime you can simple and the description I've always used is I'm like, look, you want your code to work for you. Like why do you write code? And the funny part is the most naive answer might be to make my program run. And
Hmm.
and I would say, okay, that's true, but your program's going to run. Well, I mean, I don't want to say your program's going to run regardless, but there's a lot of code that could make your program run, right? You could write the same program 10,000 different ways.
Hmm.
So clearly that's kind of an ancillary trait, right? Like that's more of a design question than an actual code question. Because, like, why did I design my program? Oh, to make it do these things. Why did I write this code? Would be more like, oh, to make it easier to write my program. And that, there is a quote and I wish I could had the perfect attribution for it, but it was in the Forager blog on Yo-Yo Games, and they were talking about the optimization done. But one of the things he said that always stuck with me was, keep your systems clean and your implementations dirty.
Hmm.
And what that
Hmm.
means is we're talking about state machines, and I have my little state machine that I wrote, and it's about 20 or 30 lines of code. And I know that sounds really
Hmm.
funny when you think about, like, oh, aren't state machines complex? And I'm like, I think mine's only like 20 lines of code. I'm pretty sure it's one page. It's very simple.
Hmm.
And oh man, I just farted on my idea there. Okay, anyway, sorry, it was the systems clean. So I have this nice simple system. It's very clean. Well, I can write dirty states on top of that because
Hmm.
it's only going to affect that one object that I wrote. So, let's go back to Mario. I'm writing a Goomba. I can write the Goomba as lazy as I want to because it's only going to affect the Goomba. And so what that quote means to me is you write this framework, and that's another issue with the Switch case is it's not very reusable, is it? You going to do a little bit of copy pasting if you're lucky when you're working with that because you can't reuse a
Yeah.
switch statement in any useful sense because it's very absolute. You can't be like case A. You have to be case state walk. Well, if this character doesn't have a walk state, which again is something that's probably very personal to this particular instance in your game, so you don't get a lot of reusability out of it either. And yeah, so it's funny. I really don't mean to pick on switch statements so much. They're really one of the first things people learn because I think they look nice. They're easy to
Yeah, they do.
understand. You're like,
Hmm.
hey, if something is this, do a thing, and it lines up all neatly, and you get a good warm and fuzzy out of it. But it's one of those tools that, like, I mean, it, Python doesn't even have a switch statement. It's like
I think now it has.
that's how I mean I don't I wish it did because there are times where you want one. But it's funny that it's like it's not even considered a mandatory part of a language
Hmm.
because there's so many better tools to solve so many problems. It's just kind of funny. And the state machine really is that poster child, or I mean, sorry, the switch statement really is the poster child of the my first state machine. Hell, if I go grab my beginner's book to C, I bet they use a switch case machine in there as well. Even though it's not a good idea. It of any level of complexity, you'll regret it. The
Hmm. One thing I wanted to circle back to is how you said that keeping, keep your implementations dirty and your systems clean. It
Yes.
was the other way around, but ignored.
No,
Um,
it was you got them both right. Just you
mm,
reversed them because you're German, and that's what it's like. I like my
Um,
idioms in reverse.
yes. Um, the thing is, most tools I've written that are really powerful in some cases, sometimes not, but that depends on the tool really. They're not complex. They're really easy, and I think that's one of the most important things to remember about state machines in particular, is that when you write a code for a state or a state machine really, it isn't something to be scared of. It's not code you will look at and not understand because it's so complex. Complex code is
Like
if you're
Perl
looking
and
at complex
noise is
code,
complex, but your state machine should not be.
if you look at complex code, you'll know it's complex code because you don't understand anything. You know there's a variable assigned there, but that's it.
Mm.
Um, like you will not write code you need to be afraid of. If you're writing code you need to be afraid of, that's going to take weeks for that particular piece of code, especially when you're optimizing it later. So being afraid of writing code just because it has a fancy name like finite state machine, it's um, I'm not sure if I can put this in a nice way, but it's a stupid thing to do because finite state machines are not complex. They're an idea that you can encapsulate an action and like divide it up. Well, the funny thing about state machines is really on begin, on step, and on leave are states inside the state machine. Um, but the funny thing is that a state machine is just another way to represent kind of an event, and you see that on objects in GameMaker, for example. You have begin step, you have step and end step, on draw, and then begin draw, end draw, and those are all again states, and you can think of objects as state machines, like you said earlier. And the thing about that is, what I really liked, what I didn't know before, and I'm glad you brought it up, is the truity of those states. Because if you're writing a good state machine, first of all, the solution is elegant. Like you have that 30 lines of code, and it's not a lot. But on the other hand, when you're writing a good state itself, um, you will know for sure that when you do on begin and then on step, that you will know for sure that this is true for this state and this will work for this state always. Because otherwise, you're not writing a good state.
Yes, yes, I could agree, and that's where. And I won't go off to too more tangents. In fact, I'll say what we should do is we'll throw in some like personal best practices or something of that nature here, just to sort of sum up what we've been talking about. And and I like what you'd said because you will find that good code is usually like useful code is usually pretty easy. And that kind of intersects with what I was talking about where why do you write code? To make things easier on yourself. Well, if your code is hard to use, you're not really making things easier on yourself. And sometimes you can't get away from it. Some code's complex. It happens, but a lot of it isn't. A lot of it isn't. And your fundamental code, ooh, please don't be. I mean, like, I'm going to go off on a very small tangent here, which is interface code is very painful to write all the time, and I don't think I've ever found a
Mm.
way to make it otherwise. But even then, if you have simple and easy tools to work with, the reason why interface is so annoying to write is just because it's very conditional based. This needs to lead to that, which does this and that, and you're like, okay, I want to change that, so this got to move and that, and it's the way it is. But when you get down to it, your text box shouldn't be complex. Like it just draws text, man. Like why is this so complex? Why do we have all these things happening? And yeah, so my big piece for state would be when we think about state, it is literally just the encapsulation of that one idea. It's placing a separation between two ideas and saying, and not just saying like, hey, if one thing is true or another thing is true, it's saying this is true or this is true. And when this is true, this doesn't exist. And when this is true, this doesn't exist. And that's why we break it up. Like the player's health is a state, but it's probably applicable to a wider variety of conditions of that player. But when the player's jumping, they're climbing through sewers. Information is not relevant at all. It shouldn't even exist because it's not possible for them to be crawling through a pit at the same time that they're flying through the sky. And so we go, there we go. This is your flight code. This is me flying. Here's all the flying stuff. And then here's my crawling code over here. So I don't have to worry about saying like, hey, am I going to accidentally change animations while I'm crawling to my flying? No, because it's impossible. It just does not exist.
Mm. And I don't really have to add anything to that because I think you put it very perfectly. The one thing I would add is, especially if you're new to writing code or like making games in general, um, but still not so new that you wouldn't know, is that if you can write your state into an object and just change the object for the other, so your die state and you have oh Mario alive and oh Mario dying, for example, that it would still work, that the code wouldn't crash. If it wouldn't crash, it's a decent start. It isn't necessarily a good state then, because what we just said, the truity of states. But if it doesn't crash, if it runs, and you don't have to pass a bunch of things first, like if you don't have an entire list of variables that need to be put to
That need to
the
be
current variable and
managed.
everything, then you have written a decent state and you have a good start. And you can, if you do that consistently, where if I'm going to put this in a different object, I will only have to give it the player HP value. Then you've written a good state and you don't have to worry about it. That's good enough for now, and you can worry about the great code later.
Oh yeah, I think that's perfectly good advice. So what I will say is, we didn't name this or anything, and we're just having fun. So this has been Hyomoto,
And I'm Julian, like I
and
said earlier.
I guess we'll see y'all in the future. Good
Maybe.
day or
Bye bye.
night.